Okay, so today we will discuss the different type of shift instruction. Okay, so this shift instruction actually grouped under the arithmetic instruction and logical instruction. So there are basically 8 type of shift instructions available. 8 types. There are actually 8 types of shift instructions are available in the case of the computer architecture programming language, and out of this, two are the logical shift operation, sorry, two are the arithmetic shift operation, and rest of the are logical shift operation. So we'll see one by one how this shift each of the shift operation actually performed. Okay, so first one is your logical shift left. So this is the first logical shift left. This is the first operation, logical shift left. Now what is the meaning of that? So suppose we have an this is okay, so 1 2 3 4 5 6 7. So this is an 8-bit data. Suppose this is an 8-bit data, and the data is suppose 1 sorry, data is 1 0 1 0 1 1 1 0. So this is suppose an 8-bit data. Now we want to shift this data logically left. Then what will happen? So left shift means each of the data will be shifted to its left position. So like, so this data will be shifted left. So this data will come here 0 1, this data will come here, this data will come here 1, this data will come here 1, this 0 will come here 0, this 1 will come here 1, this 0 will come here 0. Okay, and in the last we have put 0. So that is the meaning of the logical shift. Now just by seeing in this data you don't realize what is the meaning of that. So I am just taking a simple example. Suppose I am taking the binary equivalent of 10. So binary equivalent of 10 is 1 0 1 0. So 0 1 2 0 1 2 3, so 3 8. Okay, 4 5 6 7 8. So this is your original, suppose this is your original 8-bit data. Now we want to shift it left. So 0 1 0 1 0 0 0, and the last bit, whatever this bit is actually dropped. Okay, whatever this bit, last bit, this is actually dropped, and we have put here the last one 0. Okay, so you can see also from here that here this is your 0 1 1 1 0 1 0, and this is actually drop data, and instead of that we have put here 0. Okay, so this is the actual meaning of the logical shift left. So you don't get any type of meaning just by seeing this random data, but if you see this data, this is actually binary equivalent of 10. Okay, so this is the decimal number 10 binary representation. Okay, and this is your 10100. Okay, so this is 0 1 2 3 4. So 2 to the power 4 plus 2 to the power 2, so 16 plus 4. Okay, so 16 plus 4 means 20. So whatever data we have provided here, the data has been doubled. So logical shift left means whatever data we have provided, that data has become doubled in case of its numerical value. So that is the meaning of the logical shift left. Okay, so this is a perfect example of the logical shift left. Now suppose again the next is logical shift right. So next is logical shift right. Okay, now what is the meaning of that? So here again we are taking the 8-bit data. Suppose the 8-bit data is again 10. So 1 0 1 0 0 0 0 0. So this is the final decimal equivalent of 10. Now if we want to shift the data right, so 0 0 4 zeros, then 1 0 1. This data is actually dropped in the case of the right, and here this blank here we have put it 0. Okay, so that is the logical shift right. This data is actually dropped. In the case of the logical shift left, you can see that this data is actually dropped, this data. And in the case of the logical shift right, the right data is actually dropped. Now you can see that this is the binary equivalent of 10, and this is the decimal equivalent of 10, and this is the decimal equivalent of 5. So logical shift right means whatever data we have provided before, that data has been half. Okay, that means divide by 2. Divide by 2 operation is happening with the help of logical shift right, and divide multiplication by 2 operation happening in the case of the logical shift left. So that is the two important meaning in the case of the logical shift left and the logical shift right. And in the case of the logical shift left, we have dropped the leftmost bit data and put the blank data with 0. And in the logical shift right, we have dropped the rightmost data and the blank data is put at 0. But we can find in the last that the data for the provided data and the output data is divided by 2, and the provided data and output data is multiplied by 2 in the case of the logical shift left. So after discussing the logical shift, now today we will discuss the arithmetic shift. Now arithmetic shift has two conditions. First one is your arithmetic left shift, and second one is your arithmetic right shift, like the logical one. So we will discuss this one by one. So first one is your arithmetic left shift. In the case of the arithmetic left shift, is same as this arithmetic left shift as same as logical left shift. Okay, so it is equivalent to logical shift left. Okay, there is no difference between these two, so we will just discuss with an example, very simple example. Suppose our data is 1 0 0 0 1 1 1 2 3 4 5 6 7 8. This is our data. So in the case of the arithmetic left shift, what we want to do, we just whatever we have discussed in the logical left shift, that will be discussed here. That means this one has been dropped from the final result, so this one will come here like that, this 0 will come here, this one will come here, this one will come here, this 0 will come here, this 0 will come here, this 0 will come here. Okay, see, this one is actually being dropped, and the rightmost digit is filled up with a 0. So that is the arithmetic left shift, just as the same as the logical left shift. Okay, and next we will discuss the arithmetic right shift, which is the important. So arithmetic right shift, suppose this is your data 1 0 0 1 0 0 1 0. So this is your data. So in the case of the 1 2 3 4 5 6 7 8, this is your 8-bit data. So in the case of the arithmetic right shift, what we want to do, we want to just preserve the sign of the bit. Sign of the bit, all of you know that this bit, okay, this bit, this MSB of the bit is actually holding the sign of the data. Okay, so we will not change this. Whatever maybe the shifting operation happens, the final output result will not change this bit. So this bit will, okay, remain in the output as it is. And also we want to shift the data one by one. So this 0 will come here, this 0 will come here, this 1 will come here, this 0 will come here, this 0 will come here, this 1 will come here, this 0 is being dropped. Okay, it is dropped. Just like left shift, the rightmost data is being dropped. And here in this position we have filled here whatever may be the sign of the this data that has been preserved. So that's why this data is been same. So this one has been put here, and also whatever may be the data here, that also may be put here. So this is also 1. So this is your arithmetic right shift operation, which is something different. Here the only difference is that we want to preserve the sign of the data. The sign of the data is actually contains in the MSB of the data. So that's why you want to preserve the data, and in the this data has been copied from this data. If it is 0, then it has been 0 here, put 0 here, and also here in this bit it has been also put 0 here. Okay, and the rightmost bit, this bit has been dropped. Okay, so that is the main thing about the arithmetic right shift, which is different from logical left or right shift. So we have still now we have studied the 3 operation. First one is your logical left shift, and second one is your logical left shift is also same as arithmetic left shift, and second one we have studied the logical right shift, and third one we have studied is arithmetic right shift. Okay, these 3 operations till now we have studied. Okay, one which is same as these two is same, this and this we have been studied. Okay, so next we have been now discuss the rotate operation. Okay, and also the next we will discuss the rotate through carry. These 2 operations we will discuss next. So now we will discuss the rotate operation. Okay, so rotate is also categorized into rotate left operation, and second one is your rotate right operation. Now in the rotate left operation, what we want to do, we just taken a data, suppose 0 1 0 1 1 0 1 1. So this is your original data. We want to rotate this left. Okay, now rotate left is, this is your 1, this is your 1, this is 0, left operation 1, this is 1, this is 0, this is 1. Now in the case of the previously logical shift left and the arithmetic shift left, we have been dropped this data. Okay, but in the case of the rotate left, in the case of the rotate left, we have not been dropped this data. We have put this data, just rotating this data here. So this data will come up here. So this is the difference between the logical shift left, arithmetic shift left with the rotate left. Okay, so next we will discuss the second one is rotate right operation. So in the case of the rotate right operation, what we want to do, suppose we have taken a data 1 0 1 0 1 1 1 0. So this is your original 8-bit data. So in the case of the write operation previously, logical shift right, what we want to do, that's 1 0 1 0 1 1 1. This is your logical shift right, same operation. In the case of the logical shift right, what you want to do, this data, rightmost data had been dropped and instead of 0 has been putted here. But here in the case of the rotate right operation, what we want to do, this data will come up here, so this 0 will come up here. Okay, so this is the rotate left and the rotate right. We have again see what we actually done there. So 0 1 0 1 1 0 1 1, this is the data. In the case of the logical shift left and the arithmetic shift left, just by shifting the data, in addition to that we are dropping the data of the leftmost digit and we have put 0 here, but here we have not dropped this data. Instead of that, we have put that data, rotate the data to the first position. Okay, and in the case of the rotate right operation, in the case of the logical shift right, we have been dropped this rightmost data, but here we have not dropped this data. We have just put this data to the last digit of the original data. Okay, so that is your final result. And next we will discuss the another important thing, that is rotate through carry left and rotate through carry right. So here in this operation, what we want to do, we just taken a data, suppose this is your data. Okay, instead of the data we have also considered the carry flag. Okay, carry flag is also affected, so the total size of the data is actually 9-bit. So this is, suppose this is your carry flag. In addition to that, carry flag is suppose 0. In addition to that, the original data is 1 0 1 0 1 1 1 0. So this is your original data and this is your carry. So whenever we want to perform the operation rotate through carry left, then what we actually do, we just shift the data with the carry, okay. So this is your 0 come up will here, 1 come up here, this 1 come up here, this 1 come up here, this 0 will come up here, this 1 will come up here, this 0 will come up here, this 1 will come up here, and this carry will also come up here. Okay, so this is the operation actually left with the carry. So actual operation is composed of 9 bits with the carry bit. This is your original 8-bit data plus 1-bit carry. So the total 9-bit data, we have shifted the rotate the data left circularly with the carry bit, addition with the carry bit. So this is a very simple operation. And also the second is rotate through carry right. This is also same. We have considered the carry flag and the original data. So carry flag, suppose this carry flag is 1 and suppose this is your carry flag is 1 and the original data is 0 1 0 0 1 0 0 1. This is your original data. We want to shift the data right. So whatever may be the carry flag, that will come here. This is 0, this is 1, this is 0, this is 0, this is 1, this is 0, this is 0, and this 1 will come up here in the case of the carry. So this is the rotate through carry right. Okay, rotate through carry right. So you can see that all of the 9-bit data has been shifted just like that. So we have discussed all the 8 things. First one is your logical shift left and logical shift right, arithmetic shift left, these two are same, arithmetic shift right, And next we will discuss the rotate operation. Rotate operation is to composed of left and the right rotate, left rotate, and then we discuss the rotate through carry. This is also composed of two operation: rotate through carry left, rotate through carry right. So you can see that total 8 operation is there: 1 2 3 4 5 6 7 8. This total 8 operation is actually composed of the shift operation.